Hello everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics. Today we are going to discuss about the method Newton-Raphson method. That is a numerical method we are going to discuss. This lecture includes the geometrical representation of Newton-Raphson method and the derivation of Newton-Raphson method, and we are going to solve a problem using Newton-Raphson method, and about approximate root we are going to discuss. Now this is the geometrical representation of Newton-Raphson method. This is x-axis and y-axis, the two-dimensional. It is the graph you can see here. X and y is placed x-axis and y-axis, and y equal to f of x. This is the curve. Y equal to f of x, the curve, and A is a point on the x-axis and x0 is a point on x-axis. The coordinate A and f of A, so they are joined by a small straight line, and x0 and f of x0, they are joined by the straight line, and y equal to f of x is a curve. Now you can see this B0. This B0 is nothing but a tangent. The tangent is that is a straight line which touches the curve at one point. That we will call it as tangent. Here B0 is touching our curve, that is y equal to f of x here, and there x1, it cuts the x-axis. So next B1 is also another tangent, that is which touches this curve at this one point, that is B1, whereas at x-axis it cut at the point x2. So no one, B0, the point x, it cuts at x1, whereas B1, x2. So if we continue these processes, we can get an approximate root by using this Newton-Raphson method. This method we can call it as even a method of tangents. Also we can call it as. So the Newton-Raphson method, it is a very powerful method to find the root of the equations. Now you can see it. So now we are assuming this x0 is the approximate root of f of x. Where exact roots are not possible, that is using the direct methods, then we have to find out another way, approximate a root, by using numerical methods. The numerical methods, Newton-Raphson is one of the method. So now we are assuming here x0 is the approximate root of f of x. Now x1 is the correct root, exact root. It satisfies the equation. That is the reason f of x1 equal to 0. So you can see it, this x1. So we are substituting the equation. So f of x1 equal to 0. Now x1, it's nothing but x0 plus h we have taken. This is actually, so if you are taking just one example, I'm telling 10, 20, 30. The three datas are there, 10, 20, 30. If you are taking 10 as x0, 20 is becoming x1. Yes, the 20, how we got it? 10 plus the difference. So x1, it's nothing but x0 plus h. That is 20 equal to 10 plus 10. That is the difference. So in that concept, so x1 it's nothing but x naught plus h. We are naming as equation 1. Now f of x1 it's nothing but f of x naught plus h. So it is f of x naught plus h is a rectangle to understand more. Now using the Taylor's theorem, we are going to expand. That is, f of x naught plus h, according to Taylor's, the formula is f of x naught plus h into f dash of x naught by 1 factorial plus h square into f double dash of x naught by 2 factorial plus the next it is not written, but easily we can say, because we are understanding this flow of this formula, that is plus h cube into f triple dash of x naught by 3 factorial, it goes on. So you can see it, f dash, f double dash, this is first derivative, this is second derivative. We are neglecting, actually this is the derivation using this Taylor's. We are going to derive Newton-Raphson formula. For that, we are not going to consider this. We are going to consider only the first and second term of the formula. We are going to neglect h square onwards. So that's what it is written here, neglecting h square and h cube. So it is circled. So from this, if you are seeing this green color, that is circled, the animation from this part onwards, it is, we are going to neglect. And here, if you are seeing the left hand side of the formula is f of x naught plus h. Now our left hand side, it is, so here you can see it, this f of x naught plus h equal to 0. This 0, this here we have written, because the left hand side is equal to this. Now f of 0 equal to f of x naught plus h into f dash of x naught. From here we are deriving h is nothing but minus f of x naught by f dash of x naught. So now we are going to substitute the value of h in equation 1. We know it, x1 is nothing but x naught plus h. H, the before slide, yes, it is explained, that is minus f of x naught by f dash of x naught. So now x1 equal to x naught, so here we are substituting, that is x naught plus h is taking this value, we are substituting here, then it is becoming x1 equal to x naught minus f of x naught by f dash of x naught. x1 is the now better approximation than x naught. Now we got it, x1 it's nothing but the formula x naught minus f of x naught by f dash of x naught. That is, compared to the left hand side, 1 is less. So keeping that technique, we can write it similarly, x2 equal to x1 minus f of x1 by f dash of x1. x3 1 less than x2 minus f of x2 by f dash of x2. So on xn plus 1, it's nothing but 1 less. So here n plus 1, so 1 less means n, wherever, what is n? N. That is xn minus f of xn by f dash of xn. Now we can solve a problem using Newton-Raphson method. that is f of x is given x e power x minus cos x equal to 0. So we are taking f of x equal to x e power x minus cos x. So you are seeing wherever that x, the terms are circled, because it is in terms of x. In the place of x, we are going to substitute. We are going to assume maybe 0 will be the approximate. 0 will be the root. So we are substituting. So it is becoming, if you are saying f of 0, x place we put it 0. The first one, 0 into anything, we know it is 0, minus cos 0 is 1. We are getting minus 1. That is negative value, we got it. And we can tell 0 is not a root. 0 is not a root because we know it. If it is a root, it should satisfy this equation. We will be getting the answer here 0. Next, we are thinking, we are applying. Next, we are trying the next f of 1. Then, wherever x, this rectangle, x, we are substituting 1. So, 1 into e power 1 minus cos 1. Using the calculator, we are getting the values 2.1779. The positive value, we got it. Based on the concept, there exists a root between positive, opposite sign values. So negative, positive. So there is a root between 0 and 1. 0 and 1, there is a root, there exists a root to satisfy this given equation. Now, so here to get more thing, we are finding here average, that is the root lies between 0 and 1 based on the numerical method concept. We got it. Now the average is 0 plus 1 by 2, we got it 0.5. So x naught is nothing but 0.5 because now this is the approximate root. Next, we have to find x1. To find x1, we know the formula, that is x naught minus f of x naught by f dash of x naught. Here this x naught value, we know it, that's just now we got that average 0.5. But we don't know f of x naught and f dash of x naught. These both the values we don't know. So we can see it. So understanding, it is written. So f of x. So now it's our thing. We have to find first what is the value of f of x naught. That is, what is the value of f of 0.5. So you can see it. So these the places we are going to substitute. So first f of x naught. So wherever x, it is x naught we are changing. You can see it, x naught, x naught, x naught. Next, x naught place, we put it 0.5. So 0.5 e power 0.5 minus cos of 0.5. Now, so you can see it, x naught, it is taking the value 0.5. So we calculated the value, we got it, minus 0.0532. So f of x naught, that is f of 0.5 value, we got it. So next, we wanted f dash of x naught. Here it is written f of x, this is our question, f dash x into e power x. This we have to do integration by parts or UV method. You can see it here. X we copied as it is. E power x differentiation is e power x. you can see this red small arrow marks indicates the differentiation of e power x plus, now e power x as it is written, this green arrow marker indicates the differentiation of x is 1. Then minus, here it is not written minus, it is written plus. The reason is cos x differentiation, we know it, minus sin x. Already minus is there, put together it is coming plus sin x. So we got it f dash of x. But here f dash of x naught is there. So wherever x we have to put it. You can see it, this also the arrow marks giving the how it has the changed. So you can see f dash of x naught. So f dash of x naught, you can very clear the pictures are given. X is changed as what? Completely f dash of x naught. X naught value we know it 0.5. So you can, so 0.5 e power 0.5 plus e power 0.5 plus sine of 0.5 we calculated. We got it 2.9525. So now you can see here we substituted in the formula, that is x naught minus f of x naught by f dash of x naught. So the values 0.5 minus here. So here we got it f of x naught, that is minus 0.0532 divided by f dash of x naught, it's nothing but 2.9525. So you can be substituted, you can see these arrow marks, we substituted, that is you can see here f of x naught is taking this value and f dash of is x naught is taking the value 2.9525. So the final answer we got it, calculating, we got it 0.518. So x1 it's nothing but 0.518. Now we will find x2. So x2, the formula is x1 minus f of x1 by f dash of x1. So we are writing here f of x equal to x into e power x minus cos x. We want the formula to find x2, but x1 minus f of x1 by f dash of x1, to substitute here, we know the value x1, that the last slide it was explained, but we don't know f of x1 and f dash of x1. So here the question is written, and so x, wherever x, we are substituting x1. So f of x1, x1 e power x1 minus cos x1. So you can see it. Next, x1 value is 0.518. So wherever x1 is substituted the values. So x1 is taking the values. That is, you can see it here x1, here also x1, here cos of x1. That is, x1 is nothing but 0.518. We got the value 0.0007. Next, to substitute in the formula, it is required f dash of x1. Thus, f dash of x equal to x e power x plus e power x plus sin x. Now, we want it f dash of x1. So, wherever x, we substituted x1. So, x is taking x1. Now, x1 it's nothing but 0.518. So, we are substituting here x1, here e power x1. Again, e power x1 is taking the value 0.518, sine of 0.518. So you can see it, the arrow mark, the small red arrow marks. So x is becoming here x1, here x1 is taking the value 0.518. Calculated, we got it f dash of x1. That is f dash of 0.518. It's nothing but 3.0433. We got it. Now you can see here, yes, this arrow mark f of x1, this value we are going to substitute, and f dash of x1, this value. So these two values we substituted, and we know it, this x1, it's already we derived it, the 0.518. So substituting, we got it 0.5178. So x2 is nothing but 0.5178. We got it. Similarly, now we have to find the value of x3. So for that, x3 formula, we know it, the Newton-Raphson method. It is a very easiest way to remember the formula. x3 equal to 1 less than 3. We have to write it. That is x2 minus f of x2 by f dash of x2. So to substitute, we know it, x2 value we know it, that is 0.5178, whereas we don't know f of x2 and f dash of x2, we don't know the value. So first f of x we are writing. So wherever x, it is becoming x2, x2, e power x2 cos x2. Now x is what, taking the value x2. So f of 0.5178, x2, x2, x2. So completely the x2 is taking the value 0.5178. You can see it. From x, it is becoming x2. x2 is taking the value 0.5178. So the calculation part, it is done. We got the value 0.0001. That is f of x2. The value we got it 0.0001. Next, f dash of x, it is written, but we wanted f dash of x2. So that is the reason x is taking x2. So x2, e power x2 plus e power x2. So wherever the complete x, it is changed to x2. Now x2 is f dash of 0.5178. That is 0.5178 e power 0.5178 plus e power 0.5178 plus sine of 0.5178. So you can see x changed to x2. x2 is taking the value 0.5178. Complete x2, we substituted the value. Calculation is done. So we got the value, that is f dash of x2, nothing but f dash of 0.5178 is 3.0423. Now you can see here. So now it is substituted. So you can see f of x2 is the value is taken 0.0001, and this arrow mark, it is taken f dash of x2, the value is taken 3.0423. So the calculation is done. So we are getting 0.51777. Approximate root. First, the root. If an equation, suppose alpha is a root of the equation f of x, then compulsory f of alpha equal to 0. Then we will call alpha is the root of the equation. That is the exact root. But mathematically, there is no direct methods for transcendental equations. That is, the transcendental equations means the equation which contains trigonometric terms, logarithm terms and exponential terms, and higher order algebraic terms if the degree is more than 4. So now these equations, to find the root, it's very difficult. So another alternative only, this numerical methods. Using those methods we can find approximate root. In that, today we discussed about this one of the numerical method, Newton-Raphson method. Otherwise we can call it as method of tangents. Using, we solved our equation, that is f of x equal to x e power x minus cos x. This is our transcendental equation because our given problem exponential is there, trigonometry terms are there. Now x naught 0.5, x1 we got a 0.518, x2 0.5178 we got it, x3 0.51777 we got it. So now, so if you are seeing that decimal started repeating, this is nothing but 0.517, actually 777, so we can tell 78. So 0.517, 0.517, the decimal started repeating, we can stop the procedure. We can declare 0.517 is the approximate root of the given transcendental equation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.